Okay, and good afternoon, good evening, good morning, wherever you are. My name's Kevlin Henney. I'm going to talk to you about wibbly-wobbly, timey-wimey stuff. I should explain a few things before we get there. First of all, what do I mean by all of this? And I want to rest today on our difficult relationship with time. As developers, anybody involved in software development, in fact, you will be very familiar with this observation. There's never enough time to do something right. There's always enough time to do it over. This is Melvin Conway from the very paper that gave us Conway's Law, published back in 1968. But that's not what I want to talk about, although that is a fascinating area of time. And it is indeed very wibbly-wobbly when we talk about estimates. It's our difficult relationship with time as developers and indeed as humans. You can actually see this. So here's a good example from Facebook a couple of years ago. Foolishly enough, I actually submitted a kind of a help request, or rather, here's a bug you've got. And they sent me this response. Your feedback will be used to improve Facebook. I do not believe that has happened. Thanks for taking the time to make a report. What I love about the fact that I reported a bug and they came back to me with 31st of December 1969. Now, I'm fairly sure that Facebook was not really happening there. This is a consequence of a perfect storm about how we think about time, how we program time, how we fail to accommodate time. This, if you're familiar with the idea that time began in 1970, the 1st of January, we've gone back before the beginning of time here. This is a simple error. Something got zeroed and then a time zone or a piece of arithmetic was applied and it all went slightly wrong. But it does give us the ability to travel in time. And here's me with the TARDIS. Well, it might look like a toilet, but this is the Doctor Who reference. The Doctor Who reference, and where I've taken the second season of David Tennant's Doctor, people assume that time is a strict progression of cause to effect. But actually, from a non-linear, non-subjective viewpoint, it's more like a big ball of timey-wimey stuff. And that turns out to be the case when we deal with software. We may not be Time Lords, but we actually have many of the same issues and same challenges. And that plasticity of time is also both a great strength and a great weakness. But I want to rest on another word here. We rested on the word time. I want to look at the word assume and therefore assumption. And I tweeted recently from a point of view of knowledge, from a point of view of epistemology. Epistemologically speaking, assumptions are the barefoot trodden Lego bricks in the dark of knowledge. You don't know they're there until you know that they're there. And even if you know there are some there, you don't know exactly where, and you'll still end up stepping on some. Time is the date time handling is the kind of like the natural enemy, the prime predator of software developers. Due out beginning of next month, a book that I've edited with Trisha G, 97 Things Every Java Programmer Should Know. In that, I did actually write something about the Java date, the deprecated Java date handling stuff. But in that, I made the observation, if you think you know everything you need to know about date time handling, you are almost certainly wrong. If you think you don't, you are almost certainly right. So going back to last month, World Book Day was on 23rd of April. There's a particular reason the 23rd of April is chosen. And it in part is down to this chap here, Miguel de Cervantes. He died on the 23rd of April, 1616. Date. They did not actually die on the same day. And this is where we start getting all wibbly-wobbly, timey-wimey. The first thing we have to recognize is that the day does not fit conveniently into the year. 365 days, you actually see 365 embedded everywhere in our culture. There's assumptions. In fact, Office 365, or I should refer to it as Microsoft 365 now, 365 is everywhere. The problem is that the year does not conveniently align with the solar day. The solar year is actually a bit more like this. It's just really not quite a whole number. It doesn't really work with our integer sensibilities. So every now and then you need to throw in a 366-day year. A leap year. You need to do this with a leap day at the end of February. Okay, so I'm just going to keep today's discussion very much confined on the kind of Gregorian, Julian calendar space. There are other calendars which are far more fascinating and far weirder, but even the basic stuff that we have to deal with is still surprising. The Julian leap year, the Julian calendar, which was basically used throughout Europe up until kind of up until the 16th century and a little bit beyond, and then rolled out across the rest of the world through acts of imperialism, colonialism. The leap year calculation was quite simple. If the year is divisible by 4, then it's a leap year. So that gives us the a nice piece of groovy code, gives us the mean year of 365.25 days. However, that's not quite right. It's a little bit too far from the actual value. It means the seasons start drifting. And this was observed, and in the 16th century, under Pope Gregory XIII, the Vatican decreed that it should become, there should be a new leap year, and that's Pope Gregory, Gregorian. So that's where we get it from. With a slightly more complex leap year calculation, and that this would be much better, much closer to the 365.2422, which is really quite, it's a much better algorithm, and we probably won't need to fix anything for about another 1,000 years yet. And so therefore, as a developer, you don't need to worry about this. The problem is, however, when we go back, it turns out that not everybody switched calendar at the same time. 23rd of April, 1616, that was 23rd of April, 1616 in England. In Spain, where Miguel de Cervantes died, that was actually a different date. It was the 10th of May. England and Spain were on different calendars at this point. And this whole issue of adjusting calendars is something I'm going to come back to a little bit later. But already we see that there's an interesting challenge, an interesting tension. Because I said they died on the same date, but they do not actually die on the same day. So we've got these two words, date and day. And kind of sometimes they mean the same thing, sometimes they don't. And as developers, we really should care a lot about names and time. And this has been, as it were, practiced to a fine art with something like domain-driven design. Really understand your domain. What is its vocabulary? What is the relationships between one part of the vocabulary set and another part? And this reveals the meaning of the world. And this is really quite a fundamental, but really quite important idea. So this concept is should be simple, really. I mean, surely since the beginning of commercial computing, we have had to deal with date and time handling. So perhaps we got this one right. Surely this is the area that we have got the most understanding in. So let's go and look at a couple of really widely used languages with a lot of influence, and we'll see that this actually goes further. So Java, in Java util, there is a class called date. In JavaScript, which borrows some of its library ideas from Java, there is also a class called date, which is surprisingly similar. So here's the question. There's the thing called date. Now, in my head, I've got an idea of what I would understand by the term date. So what is it? Well, this is the time of day, wherever you are, where you get to make a choice. A calendar date, a day of the month. Okay, so date can sometimes just mean the day of the month. So for example, today, certainly where I am, it's the 12th. So sometimes if somebody says, what is the date? You would just say 12th. You wouldn't say 12th of May, 2020, you just say 12th. So therefore, that's a legitimate use, although normally in the context of code, we assume a larger context. A calendar date feels like the natural default. And in fact, if you ask somebody for a date, or you talk about somebody's date of birth, you are very precise. You're not asking for the day of the month. You're normally leaning towards A. But of course, we need to accommodate surprise, something else. And yes, the bad news is an instance of date represents something else. It does not represent the two obvious uses that if you look in a dictionary, these are the primary uses. Oh, no. The the software developers were completely surprised by this in the mid-1990s. Apparently, date time handling was a new concept, and indeed, that's what they represented it as. Instead of calling it a date time, or even a time, which is the overarching concept, they chose the one word that had the greatest ambiguity and would be guaranteed to mislead people. So you can always ask people, when is a date not a date? When it's from JavaScript or when it's in Java util. If you want to be precise, it's a date time in milliseconds, but we don't need that precision. It's still wrong and surprising. So let's move on to something else. Let's talk about day. In those classes, what does the getDay method return? I mean, there's a couple of kind of obvious answers here. So a day of the week, Tuesday. A day of the month, 12th. A day of the year. Oh, actually, I don't know today's day of the year, but that is also a possibility. That's quite reasonable. And it turns out getDay represents a day of the week. Oh, okay, so that's good. So that seems reasonable, although if you were to put this to code review, your colleagues would probably say, you know what, because there's all these other meanings, you should clarify that and say getDay of month or getDay of week, because it's kind of ambiguous. So then you stumble across another method, getDate. Now, that's kind of interesting. What does getDate do in a date class? Because does it return itself? That's a kind of an interesting idea. Does it return something that actually represents the calendar date? Does it return a day of the month? Does it return a date time because that is itself, or some other way of representing that? And it actually returns a day of the month. So this is an uncommon English, or a less common English usage, where we've already established from the class name, its constructor and everything, we've already established date means date time. And now we've said except when it doesn't. This brings to mind Phil Carlton's observation. There are only two things in computer science: cache invalidation and naming things. Okay, so this is all, well, I'm not going to say it's all good. It's pretty not good. Let's dig into the result. We've got the meaning. Let's dig into the results. Based on getDate, what day of the month is it today? 12, because I said it was the 12th. 11, because sometimes we count from 0. Or something else. Well, actually, the good news is getDate surprises stop with its name. It does actually return 12. So months, the days in the month count from 1. This, in fact, it is exactly like the domain of usage. The idea that the user's domain is important. In other words, this is how we normally use dates, that for those of you in parts of the world where you still write checks for some reason, this is what you'll write. But in other cases, if you're just writing in your physical notebook, then you will write this. So yeah, this is all good. Now, buoyed up with that confidence, we've now got the next question. What do I get month? What is the current month? Is it 5? Because we count from 1. January, February, March, April, May. So that looks like those. Okay, so maybe 5, because that's also how I would write it. In other words, we've intuitively gone with that. Or is it 4 because we're counting from 0? Or because, hey, guess what? We've seen what else can happen. Is it something else? Well, this time it's actually 4. Which also puts us in mind of Leon Bambrick's observation. There are 2 hard problems in computer science: cache invalidation, naming things, and off by 1 errors. Now, there's a simple design principle here that was fundamentally violated. You can count from 0. Okay. You can count from 1. Okay. Don't do both. Okay. Pick one and stick with it. There's nothing more confusing than when you try and hedge both bets. But I have some news for you. It could actually have been worse. What do I mean by that? Well, this is how you're thinking of the year. January all the way through December. And naturally, these are the months that you would put down if you're writing it. If you were intuitively trying to use a date time abstraction that somebody had given you, and you used your expectation that, hey, surely a programmer wouldn't have been stupid enough to use 2 conventions. They obviously use 1. They've started with 1 counting, so they're going to stick with 1 counting. You would naturally assume that this would be the way it goes. Now, maybe it starts from 0 and that surprises you. That's fine. But actually, there's another story here, and this goes back to assumptions. This has not always been the case. Actually, the year used to start in March. Now, that is in spite of the fact that the word January comes from the Roman god Janus. And Janus is a god of beginnings and endings. It's a god that looks 2 ways. You have a really strong feeling that this is the boundary of the year. Okay, let's understand the Romans. The Romans liked parties. The Romans had lots of celebrations and festivals. The idea of fixed calendars, the way we are used to them now, is actually a huge cultural assumption, and one that is actually still an assumption, a bit too strong an assumption in some parts of the world. But March actually started. March was the beginning of the year. That was spring. It held spring. So accordingly, this actually means that the months count like this. And you might say, well, what do you mean they count like this? Don't you mean, Kevlin, that they counted like that? This is past tense. Oh no. Let's count in Latin. The first month is unus. Second month is duo, tres, and so on. The bit where it gets interesting, they ran out of names. So they named month 7, 8, 9, and 10, month 7, 8, 9, and 10, septem, octo, novem, decem. And they hard-coded it. Now, as a developer, you should know hard coding, not a good idea, okay? Whatever you do, somebody one day will invalidate that assumption. And by the way, that calendar change occurred. The idea that the year beginning was in January rather than March. That was a slow rollout. That's kind of started late 1500s, early 1600s, and was still rolling around. I think Britain only, no, actually that's not true. Scotland did it from 1600. But England only instituted it properly in 1752. So the year actually began at a different point, which if you're a historian makes life absolute hell. If you're a programmer, it'll make you weep. So perhaps you don't have to deal with that weirdness. But guess what? We've got other weirdness. Let's talk about years. I'm not even going to talk about is there a year zero or not. People have very strong opinions on whether or not there is a year zero, and almost all of them are wrong, regardless of whether they pick year 0 or 1. The correct answer is it depends. I'm not going to get into that today. There is a fascinating discussion to be had, a fascinating talk to be given. I'm not going to do it. So based on get year, what is the current year? 2020, okay? The one that we expect, because that's what we write down. That's what we say. That's the cultural context. Alternatively, is it 2019 because of counting from 0? Or is it something else? Well, you know, it's not going to be either of the first two, is it? It's going to be something else. This year is year 120. Okay, yeah. This is just insane. Java decided it was going to do this. And you might say, well, why on earth would Java do this? This is such a dumb idea. I mean, who would design something that badly? Well, actually, it dates back to about 1970. Java, for reasons best known to the designers, decided that it was important that given that the language was completely source code incompatible with C, that they would make it compatible with one of the most frustrating libraries you could ever have in C, time.h, and they would make sure that all of those Java developers, and therefore JavaScript developers, would be surprised by their assumptions. Basically, once upon a time, there was the idea that years had 2 digits. And so therefore, in 1970, the beginning of time, that year would be 70, 71, 72, 73. Now, they faced a bit of a problem when they approached the year 2000. What are we going to do? Is it going to wrap around? And they said, no, it's going to be years since 1900, which is utterly counterintuitive and has caused surprises, bugs galore. Okay, now, today's Tuesday. Next question. What does get day return? 1, because perhaps we're counting Monday as 0 and therefore Tuesday as 1. 2, because perhaps we're counting Monday as 1 and Tuesday as 2. Or perhaps we're counting Sunday as 0, Monday as 1, Tuesday as 2. Or perhaps it's 3, because we're counting Sunday as 1, Monday as 2, Tuesday as 3. You see, there's so many choices. And again, there's another assumption here, and this one is still culturally unresolved. How do you think about the week? Does the week for you begin on a Sunday and end on a Saturday, or does it begin on a Monday and end on a Sunday? And sometimes there are things that are hard-coded, cultural assumptions that are hard-coded here. So, for example, if you look at Lithuanian, if you look at the names of the days in Lithuanian, even without a knowledge of Lithuanian, and I have no knowledge of Lithuanian, but I have an interest in languages, and I'm looking at that going like, wait a minute, these numbers look like counting. Prima is like prima, prime, that must be first. Tresi, that must be 3. Penkta, that sounds like penta, Greek for 5. Sesta, yeah, so they've hard-coded the day numbers into the day names. The problem is, however, that it's not uniformly and universally done this way. Portuguese has a different approach. Sunday is the first day, Domingo, Lord's Day, segunda-feira, second. It's the second day. In other words, basically Monday through Friday are hard-coded as second day, third day, fourth day, fifth day, sixth day. And Sabado is the Sabbath, and that's Saturday. So you've got two conventions here. So which one's it going to be? Well, it turns out Tuesday is day 2, or Tuesday if you'd like, but perhaps not for the reason that you think. You might think of it like this, because in fact the ISO 8601 standard does specify Monday as 1, but actually that's not why C does it. C does it like this. Tuesday is 2, not because Monday is the beginning of the week, but because it isn't the beginning of the week and we are 0 counting. And this we can find, here's one of my copies, my copy of the C99 standard. This book is quite literally a lethal weapon. It's pretty thick. If you go and look at the date-time structure that is responsible for all of this chaos, you see all of this stuff. And I like the way they've rationalized it. They've done quite a good job here. And there are a couple of points to note here. First of all, we see those various surprises. We see the year since 1900, that lovely way of post-rationalizing the fact that it's actually a 2-digit year. Notice the use of the difference between of and since to allow the 0 versus 1 counting. Nice piece of wordsmithing, really good piece of wordsmithing to get around this hack, to create the hack. Days since Sunday. Days since the 1st of January. In other words, January the 1st is not the first day of the year, it's the 0th day of the year. 0 up to 365. Therefore, you get your full 366 days. Okay, so that is accommodated. There's also the nice note at the bottom for accommodating for a leap second. And there are many ways that people handle leap seconds. Leap seconds cannot be predicted necessarily in advance. XKCD has this lovely observation. There's this idea of leap day smearing. You don't actually add a second to one of the minutes or the last minute of the day. What you do is you make all the seconds in the day a little bit longer so that actually over the day it ends up in the right place. So you still have 86,400 seconds in a day and everybody's happy. It's just that your seconds are a little bit off, but you wouldn't notice that for everyday usage. Perhaps maybe we should employ leap smearing for dealing with leap days. Now, that's the interesting thing. There's more assumptions here. There's a really interesting assumption there about the number of days. The maximum number of days that can be accommodated in the C library is 366 days. I want to show you where this is broken as our last act. How did people migrate from one calendar to another? In the Vatican and associated Catholic territories, they went from the 4th of October, which I believe was a Thursday, to Friday the 15th of October in 1582. In the UK and dependent territories, they did this in 1752. It was an 11-day interval there. They went from the 2nd of September straight through to the 14th. And in Sweden, the following year, they went from 17th of February through to the 1st of March. But the thing is that this was not the first time Sweden did this. This was Sweden's second attempt. Sweden has one of the most creative calendar adoption approaches ever. Instead of doing, and I'm all for incremental development, but in 1700, there was this idea, instead of switching all at once from the Julian calendar to the Gregorian calendar in one go, we'll take the hit, big bang deployment, we're going to do this. They decided to do incremental deployment. The idea was that 1700 would not be a leap year, as was dictated by the Julian calendar. Their idea was that they would, for 40 years, have no leap days. And slowly but surely, like the space ballet scene in 2001: A Space Odyssey, there would be this gentle docking of the Swedish calendar as it moved from the world of the Julian calendar to the Gregorian calendar. And eventually it would dock and they would reintroduce leap days. This is an insane scheme and it did not work out. Partly because Sweden at that point was fighting with its neighbors in the Great Northern War. So in 1704, they added a leap day when they said they wouldn't. 1708, they added a leap day when they said they wouldn't. They were fighting a war. They didn't really want to mess with their calendar. They were busy with other things. This didn't seem very important. 1711, Charles XII said, this is ridiculous. We're going to go back to the Julian calendar. So in 1712, they realigned with the old calendar. They did this by having 2 leap days, 30th of February, 1712. In fact, you can actually see here is a document from that period. And to help you, I've focused on the fact Februarius, February, the Latin for that, and there is day 30. They did this, and therefore in Sweden, the Swedish calendar has or had 367 days in the year of 1712, thus breaking a fundamental assumption that people have. Now, In that, I think we can also see something else. Whenever you look at some of this stuff, both what the developers have done, but also the way that people have created these things as acts of politics and religion, the observation of Anderson's law applies. I've yet to see any problem, however complicated, which, when you looked at it in the right way, did not still become more complicated. So I will close this thought. Whenever you're dealing with date time handling, if you think you know everything you need to know about date time handling, you are almost certainly wrong. If you think you don't, you are almost certainly right. Thank you.